Hi everybody, welcome back to Unit 5. I believe this is Lesson 4. And in this lesson, we're going to talk about how you name compounds that have more than two elements. Up until this point, we've either been naming a metal to a nonmetal to a nonmetal, or a semi-metal to a nonmetal. Well, what happens if there's more than two capital letters in there? What do you do then? It's a different set of rules, sort of. Okay? So if there's more than two elements present in the formula, then what you have in that formula is something called a polyatomic ion. Poly means many, and atomic refers to atoms, and ions mean they have a charge. So what a polyatomic ion is a group of many atoms that stick together and function as a unit, and overall that unit of atoms stuck together has a positive or negative charge. Polyatomic ions are given to us in our reference tables. They're found on table E as in Ellie or Eric. And again, it's just a group of atoms with a charge that functions as a single unit. So what you want to do when you have more than two capital letters is you want to go to table E. I always say if you see 3, as in 3 capital letters, if you see 3, go to table E. So when you see 3 elements, go to reference table E, and you'll find the polyatomics here on the table. And so what you want to do when you see 3 is go to table E first and identify your polyatomics and write down its name. And then what you do depends on who your polyatomic is with. And there's really 3 situations. And here's where I'd like you to take out a sheet of paper so that I can tell you what those 3 situations are, and you could write it down, and I'll tell you what to do. You can even use, if you want, that sheet that we did, the how to name a binary compound with a metal in it. It doesn't really matter. So somewhere on a sheet of paper, we're going to write this down. Okay? Not in our notes. So when you see 3, go to table E. You have a polyatomic. Oh man, that's not even close to right. All right, so you have a polyatomic ion. The first thing you want to do is identify your polyatomic ion, or ions, because you might have 2. Okay. The second thing you want to do is identify who it's with. Okay? And there's 3 scenarios as to who it could be with. I lost the page here. So these are your 3 scenarios, and again, you're going to continue to write this down. It could be with a metal. I'm going to use Pa for polyatomic. You could have a positively charged metal with a negatively charged polyatomic. And in naming that, what you would do is name your metal. Again, you have a flow chart for this, but I want you to write it down the first time so you know what you do. Whenever you have a metal, just like with it was binary, you have to look up your metal and see if your metal has more than one charge. I'm just going to say, if necessary, add parentheses after its name. And of course, just like with binary, you'll need to figure out what goes inside those parentheses and put it in Roman numerals. Again, remember, that's the charge on your metal. So if your metal has more than one charge in the box, you still need parentheses after its name, okay? Then you simply just name the polyatomic. You don't do anything to the ending. You just take the name right off the table. And I'll show you an example of this in just a minute. But that's one scenario. You could have a metal with your polyatomic. And basically, it's the same as with when you had a metal to a nonmetal. You name your metal, you look up your metal. If there's more than one charge in the box, you add parentheses after its name and figure out what goes inside those parentheses. The difference here is you don't have to drop the ending of the polyatomic and add IDE. You take the name of polyatomic right off table E. So that's one scenario. Another scenario you could have would be to have a positive polyatomic and a negative nonmetal. Okay? There's really only one real positive polyatomic. Well, there's a couple, but the one they get the most is ammonium. Another one is dimercury. So there's a couple positive polyatomics. This is pretty easy too. Here you would name your polyatomic. Then you would name your nonmetal, drop the ending, and add IDE. And then really ID3, IDE. And then really the third scenario would be if you had two polyatomics together. Okay? If you have a positive polyatomic and a negative polyatomic, this is probably the easiest situation to name because you simply take their names off table E. In the order that you see them, so don't mix up any order. That you're not allowed to do that, okay? So in our notes, I think we have a couple practice. I'd like for us to try a couple and see how we can do together, and then we'll do more of this tomorrow in class. So if you flip to about the 4th page in, there's a chart. It looks like this. It says name each non-binary compound below. I'll do the first couple, maybe the first 3. Okay? So the first one is MgCO3. There are 1, 2, 3 capital letters. When you see 3, go to table E. So we're looking for something in table E that's also present in our compound here. And if we go to table E, here, what you may notice is there's this, right here. I'll just do this one here, MgCO3. So if you go to table E, you'll recognize that the CO3 is right there. This is our polyatomic. This is our metal. So we name our metal magnesium. We go to the box for magnesium. It only has 1 charge. So you do not need parentheses after its name. You name your polyatomic. This is called magnesium carbonate. That's it. That's all you do. Okay? Looks pretty easy, right? Let's try the next one. It gets a little bit more confusing. We have Fe3PO42. So there are 3 capital letters here. If you see 3, go to table E. What you should see on table E is this thing, which is called phosphate. You take its name off table E. This is on table E. What's with the polyatomic here, what's coming first, is a metal. And by the way, if a metal is with the polyatomic, the metal will always come first. You name your metal. If you go to the box for iron, there's more than 1 charge in the box. So you add parentheses after its name. Okay, now we have to figure out what's inside the parentheses. We do this the same way as when we had the nonmetal. So we don't know iron's charge. We put an X up here. Shh, shh, shh. We do know phosphate's charge. You can get that off table E. If you look on table E, right here, see how it says PO43 minus? That means phosphate has a -3 charge. I forgot where I was. Here. So we'll give phosphate a -3 charge. That's all on table E. So again, remember, we need a neutral compound. Bottom times top, 3x. Use this number outside the parentheses. That's how many phosphates you have. Bye, guys. Bottom times top, Have a nice holiday. Will I see you? Oh, I'll see you Friday. Right? 3x, bottom times top, 2 times -3 minus 6. That all has to equal 0. 3x equals 6. X equals 2. So this is iron, Roman numeral 2, phosphate. Why don't you try one? Just try one for practice tonight, and then we'll do more of this when you come in tomorrow. The one I would like you to try is this one, CuOH2. Why don't you try to go ahead and name that compound? It's right in your packet, and I'll see you everybody tomorrow. Have a great day. Bye-bye.